Hello, everyone. This is Lab 9, and in this lab, we're going to talk a little bit about hypothesis testing and comparing group means. So the first thing we want to do is we want to make sure that we create a little script over here and make sure we load in all the packages that we're going to be using. So the packages that I'm going to be using here are first of all, the easy packages, right? This is a package that takes care of packages. And hopefully you have that already pre-installed. All right, let's see. And then when this one loads, we want to use the library's tidyverse. This is a package that handles data. And then I'm going to use also a package that is called rlist. This is going to help us, play around with little lists. You'll see that in a second. The package site is very, very useful, has a function described by. And now ggplot is a part of tidyverse, but just throw that in here just in case it doesn't load with tidyverse. So these are the main ones that I'm going to use, and all the other codes are going to come from the from R itself. So let's go ahead and run those. Once again, if you don't have the packages, you can go down there at the bottom right and install them for the package tab. And it says here that all of them are here. Excellent. So then let's go ahead and introduce our data set. The data set that I'm going to be using is first the data set QS3 small. If you want to look at it here, this is an old questionnaire that I had asked. It's similar to the questionnaires that I had asked you in the class. And as you can see here, we have age, gender, and some understanding about the lectures, the labs, and the study. We'll load that in. And so let's go ahead and make sure that this is the case. So we want to save this code, save as, and make sure you save it in the same directory as the data. You can give it whatever name you want. I'm going to save it as Lab09 code. And then go to session, set working directory to source file location. This way, R knows that it's going to find everything that we give referenced to by the place where it has the code. So the way that we read data in is we first, just give it a name. Let's call it QS3, questionnaire 3, QS3. And then you set it equal to the command is read.csv. All right. So with a read.csv, you just need to tell it where to go. And now remember, everything is referencing based on where we are right now. As you can see here, the working directory is going to be different from all of you, but it's going to be the same as the one that you have the data. That's why when you first start R, you should basically clone the directory, make sure you copy everything that is there. So anyway, I'm going to ask to read, let's see what the name of the data set is. It is QS3 small.csv, QS3 small.csv. And I'm going to select and run it. And there you go. It's inside here. You could always just click here, or you could actually type view and then just the name of the variable, QS3, or the data frame, or whatever, and it pops up down here. Okay. All right. So that's my data set. And what I want to do is I want to try some sort of summary statistics, a little bit of graph, and then a t-test. Let's pull up the notes for this lab. The first thing we want to try is we want to describe the column lectures. So again, describe is a function that is inside the site package. So what we need to do is describe QS3 and just the name of the variable we want to do. So let's do lectures. If you do it like this, and you run it, you see here a description. And as I said, these are the basic statistics, the mean, standard deviation, minimum, and so on and so forth. All right. Very simple, very straightforward. We've seen in the past that you can do other types of summary statistics, but this is good enough for me now. And then what I want to do is I want to do basically the same thing, but now by the two groups. In this data set, we have genders. These are male and female. It's whatever the student is identified with. And you can always do some sort of analysis by whatever group you want. So the describe by does this trick. That's a capital here. And then you just need to tell it which variable to analyze by what variable. There are various ways to do that. So one way that I find that is very straightforward is you just say what output variable you want. So in this case, lectures, and then this little tilde by gender. And then you just need to say data equals QS3. So that's one way to write it. There are other ways that you can write this. So if I analyze it like this, should write QS3. There we go. And if I run it like this, here's your data set down here. This is for gender F and for gender M. All right. Now you may want to do some other summary statistics, but let's say if you want to take these two and kind of put them together, one way to do it is by utilizing the list R bind that I have here. So assume that I want to see how this thing works. Then first, I'm going to name results1 equals this described by. And if I do that, you will see that this yields a list. So a list in R is basically multiple data frames put together. And if I click one, I get all the information. If I click the second one, I get the information. What I want is I want to see them one after the other. So the way to do that is utilize the command, the command list R bind and give it another name. So you can call it whatever you want. I've decided to call it K here. So K equals list.rbind. So this command basically binds the different lists by rows, and it's expecting like similar type lists that have the same variables, I mean, and it just puts one next to the other. If I just type K and I run it, this is the same thing as view K. And as you can see now, we have both of them attached to each other. This works only if they have the same variable names, which in this case they do. Right, so this way you just put them together, and perhaps you want to save this as some sort of output file. Maybe you want to write.csv something, so you do write.csv, and then you tell it save this data frame, and then you can give it whatever you name you want. So this would be basically summary of lectures, I don't know, by or versus or whatever, versus gender. All right, don't forget to put .csv at the end. And so this basically allows you to just save this as a CSV file. Note that again, it's going to be on your folder here, and it's going to be summary lectures versus gender. And there you go. Okay. And it is a good idea to do this because you want to have the output in a format that anybody can read, independent of whether or not they have R in their computers. All right. So the next thing that I want to do after the summary statistics, and yeah, you can do this for the labs or whichever other variables you want. So the next thing I want to do is I want to create some sort of side-by-side box plot of the lectures by gender. So let me go ahead and grab the next part of the code. We have used ggplot before. Let me go ahead and put it here. As you can see, you need to just call the data set, right? And which variable you're analyzing. In this case, I want to do lectures. And by what variable. So on the x-axis, I'm going to have the two genders. And on the y-axis, I'm going to have the lectures. This is going to create a box plot. You can see it by this stat box plot. And the error bar is going to give you the two, the top whisker, bottom whisker. The geom box plot is the one that actually graphs it. And you know me, I like to put the mean of the data set in there as well. Theme classic, you'll see how it looks like. And then at the end, save everything as P1. And if you run this, and yeah, this should be indeed. They have changed this function Y to just function now. So let's make sure we change that. And there you go. So these are the two side-by-side box plots, one for the female, one for the male. Now, if you want to save this again, you just need to save the same plot that you created here and just give the file name. Note again that this is going to be saved in the same directory as everything else. So if you look in here, you will see that the I think it's this one, box plot gender versus lectures, and then it is. All right. Again, it is a good idea to save it as a JPEG or as a PDF because you don't want to be using R later on. All right. So now we have the side-by-side box plot. Let's try to do some sort of like t-test comparison between them. And I told you in class that SAS and R will take care of that for you. What you need to do is you need to use various codes, but it depends on what type of t-test you're going to be doing, right? So the easiest one is going to be the independent, but you also might use a pool test. All of them are handled more or less with the same technique. It's called the t-test, and that comes as the standard inside R. So the command is literally t-test, and you just need to tell it what variable you're analyzing by what kind of group. And this is a standard way to do it. QS3 $ lecture, it says like use the lectures variable, and the grouping will come from gender. And note here the variance equals true. This is when you know that the variances are equal. So in this case, you use a pool t-test. And when I run it, you will see here are the results, right? It gives you the t value, the degrees of freedom it chooses, and what's the corresponding p-value. As you can see, the p-value is now 0.5. So reject the null hypothesis, right? But this is if the two variables are, if the two data sets have the same variance. The test for independent is practically the same, but the only thing you change is the argument at the end. So let me copy that in, and it's exactly the same thing, but notice here the var equals false, right? So we are assuming that the variances are not the same. Now, when I run this, note the following, that, practically didn't change. The p-value did change because remember the way that we compute, for example, standard error and degrees of freedom is much different. So there, okay. And again, I now notice that the independent t-test in R, there's a slightly different way of how to compute the degrees of freedom. All of these are heuristics anyway, so it shouldn't matter that much. And to be completely honest with you, in my life, I have found maybe like 1 or 2 examples when these two gave me something different. That doesn't mean that we don't try to figure out which one of the two is the best, but honestly, the punchline is probably not going to change. All right. So anyway, similar codes, you just change one thing, and by default, SAS and R will do a 2-sided test. If you want to change that into a 1-sided test, you can just use this code. And again, this by default again is going to do alternative less if you do it, alternative greater, or what's it called? 2-sided if you don't specify this at all. So again, if you run this, note what changed is that basically the p-value is now half, right? Because it's only using half of it. But in all 3 cases here, the p-value is greater than 0.05, so we fail to reject the null hypothesis. There doesn't seem to be any difference, or better yet, we don't have enough evidence to suggest that there's a difference in the understanding of the lectures by gender, at least in this data set. Okay. So yeah, it's just a one-thing computation, and other things that you can play around here, you could play around basically with a confidence level. So if you put that as an argument, all right, so this will do confidence level 0.90, or in other words, the confidence interval that I'm going to get down here is going to be a 9% confidence interval. Note again, the p-value doesn't change, obviously, but this changes, right? And what is this confidence interval? This is a 2-sided 90% confidence interval around the difference between the averages of the males versus the females, right? And as you can see, this is around 0. There are some positives, some negatives. That's why there doesn't seem to be any difference between the two. And finally, what I have here is I have 2-sided and another, basically, the question is then, should I be using equal or should I be using non-equal? And I'll give you now the corresponding F test, but we'll wait a little bit until we actually figure it out. It's called the variance test, and it's very simple, just var.test. And you just have to say again which variable you're analyzing based on what groups, QS3, what data set you're reading it from, and the alternative is 2-sided, right? So this variable, the variance test, is basically checking if the variance between the two groups is the same. And if you run it, note that the null hypothesis is that yes, the two variances are the same. The alternative is that they're not the same. In this situation, we get a high enough p-value, so we shall suggest we don't have enough evidence to suggest that they are actually different. So we'll go by the variances are equal. Therefore, in this situation, I should have used the t-test with pooled, or in other words, equal variances, right? We'll get back to the F-test later on when we'll learn a little bit more about it. But literally, this is it. I strongly suggest in any situation that you're comparing two groups, try to do a description of it, summary statistics, I mean, by groups, followed by some sort of box plot by groups, and then finally your appropriate t-test. All right. And that's it for this lab.